Hi all, welcome to another session on Python for data engineers. In this session, we will be talking about a basic concept that every data engineer or a Python developer must be aware of, which is virtual environments. So first of all, these are the objectives of today's session. First, we will talk about what is virtual environments, why do we need it, and then we will move on to see how to create virtual environments with some hands-on practice. So to begin with, what is virtual environment? It is an isolated Python environment. So as a developer, you will be working on different projects, and each project may have different packages or dependencies. So suppose you're working on a project A, and then there was a bug in one of the legacy or a very old project, which is, say, for example, project Z. So um, your manager has requested you to pause your work on project A and immediately fix that bug error with the project C. So Project C uses a different version of packages compared to the Project A that you're currently working on. Project C is very old. So when you try to immediately test it, you're getting some errors because the dependencies are not satisfied. So that is where virtual environments comes into place. When you are working on multiple projects and each project requires different versions of different packages, um, you can create a separate isolated environment for each project. And in that way, um, without having any conflicts, you will be able to smoothly work on them. So what we see here is it allows you to install packages without affecting the global Python setup. So when you install Python in your PC, in your system, that Python version is your global Python version. Say for example, if you have installed the latest version, I think it's 3.13 as of now. But if you want to install some package, some connector for Snowflake, the Snowflake Python connector doesn't support the latest version. It should be something less than 3.12. So you won't be able to use that connector. So you need to go down and use a stable version of Python, maybe a 3.1, 3.10, something like that. So this is why when you want to work on a project that involves Snowflake connector, you can have a separate virtual environment that has a compatible Python version. And when you are working on something different, something that requires the latest version of Python, you can create a separate Python virtual environment and have a different version of Python and work on that. So you will get more clarity when we do some demo. It's not just about Python version, it's also about different packages. So you can create different environments for different projects, each with its own dependencies and Python versions. So that is the purpose of creating a virtual environment. So by this time you might have an idea why it's needed. So we are addressing some problems and how virtual environment help with this. Conflicting dependencies between projects. Suppose the project that currently I'm working on requires Pandas version 1.x, and another project requires Pandas version 1.y. So when there is conflicting dependencies, virtual environments comes handy. You can have two separate environments. One has Pandas version 1.x, another has Pandas version 1.y. So in that way, without any conflict, you will be able to work on those two projects in the same system. You just need to switch environment. Risk of modifying global Python environment can be avoided by using virtual environment. Different projects require different package versions. So project specific versions can be installed within your virtual environment, and it is also useful for easier deployment and reproducibility. Suppose you have developed a project and then you need to demonstrate it, or you need to pass it on to your QA or your tester. They will be having a different Python global version, a different set of all the packages. So when you create a virtual environment, it's very easy to um, kind of copy all the versions of the different packages you have installed in a text file, and you can share it with them, and with a single command they will be able to reproduce that. Okay, so let's do some hands-on practice now. Before that, to create virtual environments, first, I will be talking about how to do that using venv module, which when you install Python version 3.x, anything above 3, when you install it, this package comes with it, so you don't have to explicitly install it. And then, of course, to run the commands, you need to have access to a terminal. It can be a command prompt or a bash or a VS Code terminal. So I have a folder here. Inside this, I'm going to be working on all my projects. So for example, first I have a project A. So let me open my Visual Studio Code. For that, within this folder, I'll open command prompt, and then if I type code dot, that means it will open Visual Studio Code, and by default it will open this project folder. So you don't have to manually go into this project folder. Okay, I have the Visual Studio Code open here. So what I'm going to do is let me create a folder for my project A. Okay, so I have created the project. If I list, I can see that there is a directory. You can you can check in the UI as well. So there is a folder created. Now to go inside the folder, cd my project A. And now if you check inside this folder, there is nothing. So my project A, there is nothing. So I have completed the first step. Next is we need to create a virtual environment. For that, what you can do is you can type Python -m. You can just click the right arrow and Copilot is suggesting something like this. So Python -m venv, this is the command. So this will create a virtual environment named venv. If you want to give another name, you can give another name as well. Okay, so before that, let me show you something. Python, if you want to check the Python version, currently I have Python version 3.10.2. And if you want to see what are the different packages installed, I haven't yet activated my virtual environment. I'm still in my global. So I have so many projects, so many packages within my global environment. Now I want to work on a new project, and I want to uh, start on a clean slate. So first I need to activate the virtual environment. So for that, the command is this is the command. So before that, let me show you something. Previously, when we checked this folder, there was nothing. Now we can see that there is a venv folder created when we ran the command Python virtual environment creation. And then there is a scripts folder, and there is an activator file here. So we just need to call that to activate the virtual environment. So just note here, currently we have PS and then the folder name. So let's see what happens after I execute this. Now you can see there is the name of the virtual environment within the parenthesis. This is how we can verify that the virtual environment is activated. So we have done few steps. First of all, we created a project folder. Within the project folder, we have created a virtual environment, and then we have activated the virtual environment. Now let me do a pip list, and you can see that only two. So these are the two basic packages that comes uh, or installed by default when you create a virtual environment. There's nothing else. Now I can start installing whatever packages are needed for my particular project. Say for example, my project requires pandas, requests. Okay, for now I'm just gonna demonstrate two packages. So it will start installing these packages within my virtual environment. Okay, just let's wait for this to finish. Okay, it is complete. Now let me do the pip list again, and I can see that I have more packages. Pandas. When you install pandas, NumPy, and some other packages will automatically get installed. Similarly, with the request, some other packages, URL lib3, etc., will get installed as well. Okay, so this is how we can create a virtual environment, and then we can start creating our Python script and work on our project. Let me show you some other commands. If I do a pip freeze, this will show you the different packages that are installed within your environment along with their exact version. So now that you have completed your development and you want to pass this project to your QA team or your testing team, then what you can do is you can do a pip freeze, and then whatever pip freeze is outputting, you can write this output into a requirements.txt file. Okay, so now let me go to my UI and go inside project A. I can see this requirements.txt. Let me just open it. So whatever we have seen in the pip freeze, that is what we see here. So now when we provide our code to our QA for testing, we also provide this requirements.txt file. So now let's assume that our QA um, is working on your project. So they want to test your code. So let's come out of this folder. Now I'm in the env demo. Let's create a folder for QA. Before that, let me deactivate this virtual environment. So I can do that by using deactivate. Now if I do pip list, I can see now I'm back in my global. So I have all those packages. Now I'm going to create a project or a folder for my QA. Now let's assume that this is another person, another computer. So mkdir QA project A. Okay, let me go inside this QA project A, and let me create a virtual environment inside this folder. So for that, the command is venv scripts activate. Oh, okay. I haven't created the virtual environment yet. So first I need to create the virtual environment. So for that, the command is python So first we need to create a folder for your project. Then you need to create a virtual environment, and that is when this folder structure will be created. Let's go to the UI and verify it. Now QA project A has this VENV folder. VENV folder will be created only when you execute this statement. Now I can activate that virtual environment. So this is a different folder. So if I do a pip list, what can you expect? Only two, the pip and setup tools, because this is an entirely different or isolated virtual environment. Now I want everything in that project A to be installed in this virtual environment as well, because this is going to be used by the QA team. So they need the same version of all the packages I have used in my project so that they can test my project. So what I can do is I'll go to project A, copy this requirements.txt file and put it inside here. Now what I can do is pip install. So instead of installing it directly, what I do is -r and requirements.txt. So what this command is telling is whatever version, whatever packages mentioned in this file, install them, but install it with that specific version. Okay, so we just listed the packages inside our QA project. We see only two. Now we have copied the requirements file, and now we are installing the packages based on this requirements file. Let's finish that. Okay, so waiting for this to be finished. Okay, now that the installation is complete, let me do a pip list. Okay, now I have the exact copy of all the packages in my project A folder in this QA project A folder when I activated this virtual environment. If I deactivate this virtual environment and if I do a pip list, it will list everything in my global Python environment. It has so many packages. Okay, so this is how we can use virtual environments to create separate isolated Python environments so that we can work on different projects at the same time, and the dependencies of one project will not be affecting the other project. And you will also get a way to reproduce your code or deploy your code. So for example, if you have developed your project in your development environment, and then when you are ready to move it to the QA environment, you just pass the requirements using this requirements.txt file and install the requirements based on this file so that you can reproduce the same virtual environment in another machine or in another environment. So let me revise what we have seen in this session. So we were talking about virtual environments. uh, First, we talked about the need for virtual environments. It provides an isolated Python environment so that you can install packages without affecting the global Python setup or the Python setup in other projects. And we have seen some practical example. So in the demo session, we have created a project and then created a virtual environment, and then we activated that virtual environment. So once the virtual environment is active, you can see something like this, and then we can install packages within this virtual environment. We can also copy or share your so what will happen is during the development you will install a number of project packages. Once the project development is complete, once you are ready to share your code with the QA team, you will run this command pip freeze. So whatever packages you have installed throughout your development of the project, everything will be copied into this requirements.txt file, and then you share this file along with your project code to your QA team. Then the QA team will create a virtual environment in their machine and then install the packages based on this requirements.txt in their virtual environment. And then in that way, they can exactly replicate the kind of environment you had in your system, so that any errors due to dependency issues can be avoided. Um, there will be another session where we will talk about creating virtual environments using Conda. So that is considered to be a more easier or industry standard approach, because using this method, if you want to have a different version of Python, it's very difficult. You should manually install that specific version of Python in your machine and then point to it, and it's a lot of step. So instead of using virtual environments using this VENV uh, module, you can, if you have installed Python using Conda, there is an easier way to do that. We will talk about that in the next video. Thank you.